Today let us take a frame oriented problem and solve by using matrix flexibility method. In matrix method, that is in module 4 and 5, you have additional problems that are truss oriented problems. Before 1, 2 and 3, so these modules doesn't have truss oriented problem, but in module 4 and 5 you need to do the truss analysis. Instead of sway analysis, you will be having truss oriented problem. So there is no difference between sway and non-sway here. The structure are same. See, you have a horizontal load here and the structure is not separately analyzed for sway. Whatever the conventional procedure is there is enough for making the process. And you can see number of factors for sway. What are they? So you have a horizontal force which creates a sway, and you have uneven support. The support A is fixed and D is hinged. This is also a factor to create sway. So two factors you are having here, but even though the procedure of matrix method is similar. Span AB has EI and BC has 2 EI, and CD you have EI as 1. Okay, first you have to find the redundancy, and here this structure is redundant up to 2 degree. So you know the formula. How many support reactions are there? There are 3 number of reaction at fixed end and 2 number of reaction at the hinged end. So your total reactions will be 3 plus 2 is 5, and you have equilibrium equation of 3 in numbers. If you subtract that, you will be getting 2 number of redundancy. Now you have to indicate where these redundancies are. See, in the previous cases you had a continuous beam, and in continuous beam wherever you are having negative bending moment should be taken as the redundancy, isn't it? So in case of framed structure, you have to consider the supports. You need 2 redundant supports, so you can assume D as the redundancy and you can indicate F0 here. So you have F01 and F02. So in case of frames, you have to consider support reaction as the redundancy. Okay. Step 1 is decide the primary structure and indicate F0. So this is what I explained here. You got 2 number of redundancy, and what are they is you have to remove this support and write the free body diagram F3 and F4. It is taken here, and what are the applied force is F star is known as applied force and F0 is redundant force. So you have 2 applied forces here and 2 redundant force here. Note that in frame oriented problems, you no need to find bending moment. For a continuous beam, you will be finding bending moment, yes or no? To find F star value, search for the previous case, you will be making bending moment, that is fixed bending moment, to find the F star. But in case of frames, no need to find bending moment. Just what are the forces are there, you can assume it as the external force. These are the 2 difference between continuous beam and frames. The step 1 is drawing the primary structure. So this is known as primary structure. What is primary structure in definition is, after removing all the supports, you have to consider that as a determinate structure. What is determinate structure? What is determinate structure? If the number of reaction is 3, then the structure is known as determinate structure. What is determinate structure? If the sum of reactions are equal to the number of equilibrium equation, now you will be getting equal to 0, yes or no? You know 3 number of equilibrium equation and your supports will be having 3 numbers. So 3 minus 3 will be equal to 0. So if your redundancy is 0, then it is known as primary structure. So in definition they can ask what is primary structure, in the sense if your redundancy is 0, then it is known as primary structure. Now is the structure is a primary one? So how many reactions are there in support A? 3 number of reaction. You have removed the reaction 4 and 5. Okay. Then go to step 2. Select P coordinates, that is primary coordinates for internal force. So how many coordinates will be here? Note that in case of continuous beam, you took the joints. So wherever you have joints, you have considered it as a span and you have considered it as an element. But in case of the framed structure, you can observe here AB is a span and it is taken as one element, and at one element you will be having 2 number of nodes. And at BC you are not finding fixed end moment, isn't it? Now you are considering the element as 2 numbers. So before the load and after the load. So you have to consider 2 elements. Why? Because you are not considering the fixed end moment. Hence the element 2 and element 3 will be here and element 4. In case if you are having a horizontal load in between any member, what you have to do? You have to split those members and create 2 elements. This is known as P coordinates for internal forces, and you have 8 number of nodes. You have 4 number of elements. How many flexibility matrix will be there? Alpha matrix. What is the formula? L by 6EI 2 minus 1 minus 1 2. So this is 2 by 2 matrix. You have to understand. Okay, this flexibility matrix depends upon how many number of elements are there. Here you are having how many elements? 4 number of elements. Hence you need to make how many flexibility matrix? Alpha 1, alpha 2, alpha 3 and alpha 4. So note that if you have 4 number of elements, you should have 4 elementary flexibility matrix. In this previous problem, how many are there? 2 number of span, you had 2 elements, hence you are going for 2 flexibility matrix, that is alpha. If you have 2 number of elements, you will be having 4 by 4 matrix, isn't it? So what was the flexibility matrix number? 4 by 4, isn't it? Check it. Check the previous problem. If you have 2 elements, you will be having 4 by 4 matrix. But now currently you are having how many elements here? 4 elements. That means your matrix size will be how much? 8 by 8 matrix. So you will be having 8 number of rows and 8 number of columns. So before starting your sum, you can understand what is the size of your problem, and with the number of elements you can find the number of the nodes. Okay. Now compile external forces. This is the step number 3, and here you have a note. No need to find fixed bending moment for framed structures with point load. So take a note, whenever you find a problem like this, whatever the external force is acting, take it as F star. Here you have 2 number of external force, hence you will be taking this 2 as F star. Okay. B matrix consists of what? Applied force and redundant force. Yes or no? Star, B star and B naught. So you have 2 number of cases. So how many B star elements are here? 2 number of star elements, and how many naught elements are there? 2 number of elements. So your B matrix will be 4 by 8. Step is generate B matrix. Why you need B matrix is P is the force and B into F is the formula. We will be taking F star 1. So let us take this as first value and let us find the transformation matrix. Now apply the force 1. So this is F1, so we are applying the force 1 here. Now you have to take moment. Take moment at this joint A. So what will be your moment? You have force here and you have to take moment here. So what will be the moment here? What is the distance? 3, and you have a force if you need load into distance. So what is the distance? 1 into 3 is 3. Is it clockwise or anti-clockwise? Clockwise, it will be taken as negative here. Why? Sir, even though this moment is clockwise, we are taking negative moment at fixed joint. Why? Fixed joint always have what kind of moment? Negative moment. Okay, now this is minus 3. Okay, now what is the moment at joint B? Moment at this joint. Same 3, no? Load into distance will be 3. Now you have negative and positive moment at the joint B. Yes or no? This is a partially hinged structure. You have two number of members. So one will be taken as positive and one will be taken as negative. So at this joint you have two nodes. Yes or no? So at this joint how many nodes are here? 2 and 3. Hence you will be taking plus 3 and minus 3. Okay. Now at this joint you have taken this as an element. So now what will be your moment? You are exactly there at the load. Do you have any moment? Load will be there. What is the formula for finding moment? Load into distance. So you are only having load. Do you have any distance? 0. So 3 into 0 will be 0. So that's why you will be not having the moment at next joint, these two, and at this joint, that is joint C. What will be the moment? Load into distance. Yes or no? 1 into distance is 3. Now, why you are not accounting the moment is, here you can see at the joint D, what is the support here? Hinged support. Does hinged support take any moment? No. Isn't it? Hinged support doesn't take any moment. You will be having 0 moment. Hence, even though you have load into distance, the hinged support doesn't take any moment. Hence, the moment will be 0, 0. And finally, at the hinged joint, it will not take moment. Hence, it is 0. So, you will be getting all the values here. This is the way to find beta matrix 1. Now, how to find beta matrix 2? That is, apply a force 1 kilonewton at the F2. Now, the second force comes to action. Now, how to find the bending moment at joint A? How to find bending moment? Force into distance. What is force? 1 into distance is 3. So 1 into 3 is 3. Now this is a fixed joint. What do you have to make? Negative moment. Hence it is taken as minus 3. Okay. Now what will be the moment at this joint? Joint B. 0. Why? Because load is there. You are not having any distance. Hence you will be getting 0, 0. And what is the moment at this point? You are not having any distance. Hence load will be there. Distance is 0. Hence the next two component will also be 0. And similarly for the joint C, 0, 0 will come. At the joint D, why it is 0? Joint D is hinged, hence it is 0. So this will be your transformation matrix, that is beta matrix. Okay, now let us go to next redundant, that is F3. Apply F3 naught equal to 1. What is F3 naught? You have assumed it as horizontal force. Now you take moment at the joint A. What will be the moment here? Both joint A and D are at same level. Yes or no? So you don't have load into distance component. So it is along the axis. Hence the moment will be 0 here. Okay. Now what is the moment at joint B? This is the force. How to take moment? 1 into 3. So you are taken here, it is acting clockwise and you don't have any fixed end, hence you can take it as plus. So you have plus 3 and minus 3 at this joint. Now at the place where you have the load, so this is the next joint, what will be your moment? Force into distance, that is 1 into 3. Isn't it? So your moment is 1 into 3, you can take plus 3 and minus 3. Now at the joint C, what will be the moment? 1 into 3 will be the moment, you can take plus 3 and minus 3. Hence you are seeing at the 3 joints you can 3 plus 3 and minus 3 here, and at joint D there is no distance, only load is there. Hence load into distance will be 0, you will be getting 0 value. This is the transformation matrix. So you have assumed F naught 4 equal to 1, and this is the vertical force. And if you have vertical force, now find the moment at this joint. So what will be your moment? What is the load? 1 into, what is the distance? Is it 3? Is it 3 or 6? So load into distance is 6, you will be taking it as 6. Now what is the way of action of load here? This is anti-clockwise, you have to assume it as the opposite known as clockwise, that is 6. Now it is taken as plus 6 here. Note that it is a anti-clockwise movement, hence you are applying the opposite sign. Whereas in the previous case you got positive moment, that is the moment in positive, you have taken opposite it as negative. Okay. Now at the joint B, force into distance, what is the distance? Force is 1, distance is 6. So force into distance is 1 into 6 will be 6, and at the joint where you have load, what is the, now I am taking joint C. When you are taking joint C, what will be the moment here? So you have force here of 1 kilonewton, this is along the axis, hence you will be not having any distance, yes or no? Load is here and it is along the axis, you are not having distance, hence you will be having 0. So 0, 0, and at this joint will be 0. At the place where you have load, what is the moment? Force into distance, what is the distance? 3. You will be taking force into distance as 3, hence you got minus 3 and plus 3. This is the way to get transformation matrix. If you know to do this step, the problem is very easy. It is only multiplication after this process, but if you are not knowing this process, it is very hard to cross this. In matrix flexibility method, the hardest part is finding the beta matrix. If you know this beta matrix, now I have arrived the beta matrix. How many rows are here? 8 number of rows will be there. So horizontal is known as rows and vertical is known as columns. Similar to your column. Column is vertical, no? Similarly, in the beta matrix, you should have columns. So you have 8 number of rows. Y means you are having 4 elements and 8 nodes. If you have 8 nodes, you will be having 8 rows. Okay. So your answer for B star is minus 3 plus 3 minus 3, isn't it? Check the first value. You will be having beta matrix for B star and B naught. Now this is your answer. What is the next step? Finding the alpha, that is flexibility matrix. Synthesize the element flexibility matrix, that is alpha. Element 1, 2, 3 and 4. You have the length of how much? 3 meter and L by 6EI, 2 minus 1 minus 1, 2. This will be alpha 1, and what is alpha 2? See, this is the element 2 and you have the same 3 meter distance, 3, now 6 E into I. Now it is taken as what? EI equal to 2. It is given here, hence you have to take 6 into 2. The same way for the element 3, 3 by 6 into 2, 2 minus 1, 2. For final value, now you can simplify to find the flexibility matrix. Make it as common. So here alpha 1 is 3 by 6. What is 3 by 6? You can simplify it as 1 by 2. And the same way you have 3 by 12 here, isn't it? So if you simplify this, what you will be getting? So you have to make common factor. So 1 by 4 will be here, and the same way you will be getting 1 by 4. And now what you can make is, if you need 1 by 2 as common, what you can make? You can multiply it by 1 by 2 inside. So if you are multiplying 2 into 1 by 2, which will be 2 into 1 by 2 will be 1, 1 into 1 by 2 will be minus 0.5, and likewise you can make it as a common factor. So now you will be getting 1 by 4 into 1 by 2. So the common factor will be 3 by 6. The same way you multiply it by 0.5, that is 1 by 2. At every factor you will be getting 3 by 6 as common. Now you got 3 by 6 at all the elements. You can generate the flexibility matrix. See, you have 1 by 2, that is 3 by 6 is, you can take it as 1 by 2. Now the common factor is taken here, and you have rest of the values of 2 minus 1, minus 1, 2. This is the first value, and for second element, third element and fourth element. Next one, compute the A matrix. Then step number 5 is A matrix, which consists of A naught naught and A star. A naught naught and A star. How to find that? The formula is B naught transpose, alpha and B naught. If you want to find A naught star, the formula is B naught transpose alpha into B star. Now you substitute B naught transpose. See, you have B naught. What is B naught? 0, plus 3, minus 3. These values, you should take only these two columns as B naught and this column as B star. Now you have to multiply B naught into alpha matrix. So this is alpha matrix, and if you multiply with this, you tell me the answer. Multiply this row and first column. Row into this first column. See, it might be looking too big, but if you multiply each and everything, it will be very small. See, you don't have any component for all these elements. If you multiply, first component will be 0 and second component will be 3 into minus 1 is minus 3. So the rest of the component will be what? 0 only. It is easy to calculate. If you multiply this rows into next column, the same way you will be getting 3 into 2 as 6. That's all. So first component and second is over. Then this row into this third column. Now the active components are what? Third row. Third and fourth rows are only active. You can multiply with this two only. So minus 3 into 1 will be minus 3, and 3 into 0.5 is how much? Minus 1.5. So minus 3 minus 1.5 will be minus 4.5. Okay, next this row into this column. The same way you will be getting minus 0.5 into minus 3 will be plus 1.5 and 3 plus 3. So you will be getting plus 4.5. The same way you will be getting for these columns. Likewise, you multiply for this row, the second row and this column. So you will be getting the answer of 90, 108, minus 108 and 288. After multiplying these two values, you will be getting one answer, and by that answer you have to multiply this component, and after multiplying you will be getting this answer, that is 90 minus 108 minus 108 and 288. You need A naught inverse. For further process you can make the inverse. How to make the inverse? Interchange the component, that is you will be getting 208 and 90. You have to interchange this value, and what you can do? Change the sign of these two values. That is, if it is 108, you can change the value it as plus 108 and plus 108. Now what they have done here is they have taken as the common factor and they have divided by 18. So if you divide 90 by 18 is how much? 90 by 18, it is 5. 108 by 18 is 6, and same 108 by 18 is 6, and 288 by 18, what is the value? 16, and 18 by 2 is how much? 9. See, you got this value. Okay. Now find A naught star. What is A naught star? B naught transpose alpha into B star. Now multiply this two value, and by the answer you have to multiply this. In matrix, note that if you multiply these two value and then multiply this, your answer will not come. Matrix multiplication, you have property, you can multiply A into B will be C, but B into A is not C. There are matrix properties. If you multiply A matrix into B matrix, you will get C matrix. But if you multiply in reverse, you will not get the answer. Yes or no? This is matrix property. You have to multiply these two and then start next value. After multiplication, you will be getting the value as 40, 9, 103 and minus 54. Okay. Now this will be your A naught star. Okay. Now the step number 6. What is step number 6 is F naught. How to find F naught? You have formula A naught naught inverse, A naught star and F star. Now what is your A naught naught? You got this value already. You have to inverse that. Interchange the values. See, you got 5. See, you got 5 and 16. If you want to find inverse, what do you have to do? Interchange the value. That is 16 and 5 will come, and interchange the sign here. You have minus sign. Now you have to make it as plus sign. See, now it will be in terms of plus. First diagonal has to be interchanged and second diagonal has to be changed only the sign. And what you have to do is you have to multiply 16 into 5 minus 6 into 6. You will be getting one matrix, that is determinant. Determinant you will be getting, and with that determinant it is the value what you are getting is 9 by 44. And what is A naught star? You got this value, and F star is the two forces which are 100 and 50. Now you have to multiply these three component. You will be getting 2301 and 5293 as your answer. This is your F naught. Now the last step is generating the final force. that is P equal to B into F. Now you know the beta matrix is this value and multiply by F. What is F? F consists of F star and F naught. So your F star is 150 and F naught is 2301 and 5293, which you got now. You have to multiply row into this column. Minus 3 into 100, minus 3 into 50, this will become 0, and 6 into 5293. You will be getting the first answer. Likewise, you multiply 3 into 100, this will become 0, 3 into 2301 and minus 6 into 5293. So you will be getting the second answer, that is second row. Likewise, you multiply all the rows with this column. You will be getting the answer of 31308 for the first multiplication. Now you got the final answer. This is the final force.